Assalamualaikum and good day everyone. For this project, we analyze whether different study method affect students' quiz performance. The data consists of 24 students and the variables collected are gender, study method, study hours, quiz score, and pass status. Students are grouped into method A, method B, and method C. Using this data, we will apply statistical analysis to examine the relationship between study methods and quiz performance. Next, we will construct a 95% confidence interval for the mean quiz score. First, we calculate the sample mean using all 24 quiz scores collected from the students. The formula used is x bar equals to the sum of all x values divided by n. After adding all the quiz scores, we obtain a total of 1,660. Dividing this by the sample size of 24 students, the sample mean is x bar equals to 69.17. This means that the average quiz score for the students in our sample is approximately 69 marks. Next, we calculate the sample standard deviation, which measures how spread out the quiz score are around the mean. The formula for sample standard deviation is S equal the square root of the summation of x minus x bar square divided by n minus 1. Next, we construct a table to calculate the sample standard deviation. For each quiz score, we subtract the sample mean, which is 69.17, to obtain x minus x bar. Then, each difference is squared to get x minus x bar squared. After calculating all the square differences, we add them together and obtain the summation of x minus x bar square, which equals 1,449.36. This value will then be used to calculate the sample standard deviation for the confidence interval analysis. Next, we calculate the sample standard deviation. Using the sample standard deviation formula, we obtain S equals to 7.94. This value indicates the amount of variation in students' quiz scores around the sample mean. Since our sample size is 24 students, which is less than 30, we use the t-distribution instead of the normal distribution. The degree of freedom is calculated as n-1 equals to 24 minus 1, which is 23. For a 95% confidence level, the significance level is 0.05 and each tail contains 0.025. Based on the t-table with 23 degrees of freedom, the critical value is t equals to 2.069. The margin of error is then calculated using E equals T times S divided by the square root of n. Substituting the value, E equals 2.069 times 7.94 divided by the square root of 24, which equals 3.35. Next, we construct the confidence interval by adding and subtracting the margin of error from the sample mean. The lower limit is 69.17 minus 3.35 equals to 65.82. The upper limit is 69.17 plus 3.35 equals to 72.52. Therefore, the 95% confidence interval for the population mean quiz score is 65.82 and 72.52. The conclusion is, based on our analysis, we are 95% confident that the true population mean quiz score lies between 65.82 and 72.52 marks. Next, we will test the lecturer's claim that the average quiz score is 70 at the 5% significance level. Step 1. State the hypothesis. The null hypothesis is H null mu equals to 70. The alternative hypothesis is H1 mu is not equals to 70. Since the claim states that the mean score is equals to 70, this is a two-tailed test. Step 2. Given information. From our sample, we have sample size equals to n equals to 24, sample mean x bar equals to 69.17, sample standard deviation S equals to 7.94, population means under the null hypothesis mu equals to 70, significant level equals to 0.05. Next, step 3. Determine the critical value. Because the sample size is less than 30, we use the t distribution. The degree of freedom is n-1 equals to 24 minus 1 equals to 23. Using the t table for a two-tailed test at significant level 0.05, the critical value are plus or minus 2.069. Step 4. Calculate the test statistic. The test statistic is calculated using t equals x bar minus mu divided by s over the square root of n. Substituting the value, t equals 69.17 minus 70 divided by 7.94 over the square root of 24. This gives t equals negative 0.51. Step 5. Make the decision. The rejection region is t is less than negative 2.069 or t is greater than 2.069. Since negative 2.069 is less than negative 0.51, which is less than 2.069, the test statistic falls within the acceptance regions. Therefore, we fail to reject the null hypothesis. So for the conclusion, at the 5% of significance level, there is insufficient evidence to reject the lecturer's claim that the average quiz score is 70. This means that the sample data supports the lecturer's claim, and the true population mean quiz score can reasonably be considered equals to 70 marks.
Next, let's move to question C, to test whether the average study hours of the students is equal to 6 hours. Let's begin with our sample data from 24 students showing their daily studies hour. First, the total of study times is 148 hours. Dividing by 24 gives us a sample mean of 6.17 hours per day. Next, we calculate how spread out our data is. We find out the derivation of value from the mean and square it. Then, the total sum of square is 83.33. Then, we divide by n-1, which is 23, and take the square roots, give us a sample standard deviations of 1.9 hours. Next, we test whether the true average study time is 6 hours. The null hypothesis, H null, state that the population mean equals to 6, while the alternative hypothesis state that it's not equal to 6. We use 5% significant levels and apply the t distribution since the sample size is small. With 23 degrees of freedom, the critical values are positive or negative 2.069. Now, we calculate the t statistic. We substitute the value into the formula. The sample mean 6.17 minus the hypothesized mean 6 divided by the standard deviations 1.9 over the square roots of 24. So this become 6.17 minus 6 divided by 1.9 divided by square roots of 24. This simplifies to 0.17 divided by 0.398, giving a t value of 0.43. Since 0.43 is between negative 2.069 and positive 2.069, we fail to reject H null or null hypothesis. In conclusions, there is no significant evidence that the average study time that differs from 6 hours at the 5% significant levels. Thank you.
Assalamualaikum and good day everyone. Today, I will present question D. For this question, I use an independent sample t-test because we are comparing the mean quiz score of two different groups, which are male student and female students. Since the question used the word difference, we need to use a two-tailed test. The significance level is 0.05. Next, I separated the data into two groups, which are male and female students. For the male group, the total quiz is 812 with 12 students. Therefore, the mean quiz score for male student is 67.67. For the female group, the total quiz score is 848 with 12 students. Therefore, the mean quiz score for female student is 70.67. From the result, we can see that the female students have a slightly higher average score than the male students. However, at this stage, we still cannot conclude whether the difference is significant or not. For the male students, we have 12 quiz score. The mean is 67.67. Each score is taken and we subtract the mean, then put that difference inside bracket. After that, we square the difference to remove the negative sign. All the square value are added together, giving us a total of 844.68. Then, we divide this total by n minus 1, which is 11, to get the sample variance. Finally, we take the square root of the variance, and that gives us the sample standard deviation for the male group is 8.76. Next, for the female student, we get the total is 515.68. After that, we divide this by n minus 1, which is 11, to get the sample variance. And then we taking the square root of that variance. So it gives us the sample standard deviation for the female group is 7.08. Next, I determine the degree of freedom. Using a significance level of 0.05 and 22 degree of freedom, the critical value from the t-table are 2.074. Now, let's look at the graph. The shaded area on both sides represent the rejection region. If the calculated t-value falls outside the range of negative 2.074 and then 2.074, we reject the null hypothesis. However, our calculated t-value is negative 0.92, which is located in the middle region or the acceptance region. Therefore, it does not fall into the rejection region. Based on this result, we fail to reject the null hypothesis, which is the null hypothesis is not being rejected. This means that there is not enough evidence to show a significant difference in the mean quiz score between male and female students. Next question is, we are testing whether the mean quiz score are different among students who use study method A, method B, and method C. First, we set the hypothesis. The null hypothesis says all the mean are equal, which is mean A equal to mean B and equal to mean C. The alternative hypothesis H1 says at least one mean is different. The significance level is 0.05. Next, we calculate the group means. For method A, we add all its score, which gives 548, and then we divide by n, which is equal to 8. So the mean is 68.5. For method B, the total is 619, and we divided by 8, so the mean is 77.375. For method C, the total is 493, and divided by 8, so the mean is 61.625. Therefore, the green mean, which is the overall average of all group, is 69.167. Then we calculate the sum of square between group. After that, we adding them up. The total sum of square between group is 997.64. Next, we calculate the sum of square within group, written as SSW, which is the sum of each score minus its group means square. For method A, the square difference add up to 112. Next, for method B, the total is 163.88. For method C, the total is 91.83. So the overall SSW is 367.71. Next, we find the degree of freedom equal to 23. Then we calculate the mean square, gives the answer is 498.82. The mean square within MSW is SSW divided by its degree of freedom, 21, and then that gives us the answer is 70.51. Finally, we calculate the F statistic, which is equal to 28.52. Next, the critical value of F at alpha 0.05 with degree of freedom 2 and 21 is 3.47. Since our calculated F value 28.52 is greater than 3.47, we reject the null hypothesis. At the 5% significance level, there is enough evidence to say that the mean quiz score are significantly different among students using study method A, method B, and method C. The sample means show that method A has 68.5, Method B has 77.38 and Method C has 61.63. Therefore, Method B has the highest average quiz score and appear to be most effective study method among the three.